Greetings everyone. Today we're going to explore adding and subtracting rational functions. We do have a notes sheet for this, but it's very easy to jot down in your notebook as well. Let's just do a quick review of the rules you already know because we're going to use those same rules today with rational expressions. Remember that in order to add or subtract fractions, you need a common denominator. So we have to multiply by a factor to make that denominator the same. And so in the process of doing that, we get to carry over the common denominator, combine that numerator, and always simplify if needed. And so the idea is going to be the same, it's just maybe instead of a 2, this is a 2x. Or instead of a 2x, maybe it's a 2x plus 5. That's how we're going to expand this idea. All right, so let's jot down a few things in our notes. Again, in order to add or subtract, you need like denominators. Then you're going to simply add or subtract their numerators. Now this might require some simplifying, some combining like terms, some expanding. And then in the end, you want to see if you can simplify things again, meaning occasionally your answer in the end might need to be factored and then simplified. All right, so let's apply this to the real world. First thing, if I look, I have like denominators, okay? So check, that's the first thing we need because I see a subtraction symbol, okay? So one of the things that I like to do is I'm just gonna say my least common denominator is x squared minus 3x minus 28. So I have that common denominator. So I'm going to create a single fraction with that LCD. And my numerator is going to be the x squared subtract the entire second numerator. Because I'm subtracting all of it, I need to distribute that subtraction sign. So I arrive at a negative 12 plus x, which can flip around into this nice clean quadratic trinomial, still all over my LCD. Now the last thing I need to do, and this is going to be kind of tough to remember but easy to do because we've been doing it for a while, is I need to see if I can factor. So let's look at that numerator first. I have a constant of 12 and I need a difference of 1. So a 4 and a 3, a positive 4 and a negative 3. And in the denominator, let's see, 28. 28, that needs a difference of 3. Let's see, 2 and 14, 4 and 7. 4 and 7 is looking promising. It would need to be a positive 4 and a negative 7. All right, so I do have that one last step because I can see now that I have a common factor. So my final answer is x subtract 3 over x subtract 7. So key thing on this example, we already had the common denominator. The key thing is when you're subtracting all of it. Parentheses make a difference. So now let's talk about how do I deal with the unlike denominators. It's not as simple as just maybe a little tiny factor. Let's see. We want to find that least common denominator. I'm going to, again, continue to use LCD. And we make common denominators by multiplying, not by adding. And that might seem kind of silly at first, but it'll make more sense once you see it in practice. And as always, you may need to factor. All right, so let's start off basic, right? No polynomials, just single term, okay? Just a monomial. If I take a look, my LCD, Okay, let's put this into practice. Is each denominator once? Each factor once. So I have a 3, I have an x, and I have another x. Do you see how that worked out? If I combine the denominators, that's every factor taken care of. So then what I do is I look at each numerator and I multiply that rational expression by what it's missing. The first one has a 3x. It's missing an x. The second one has 2 x's. It's missing a 3. Do you see how I did that compared to the LCD? All right, let me distribute. So x times 2, 3 times x. All right, plus sign. Let's look at the second fraction. 5 times 3, 3 times x squared. See what happened when I did that? I just created like denominators. That's how you'll know you're doing it correctly, is you'll arrive at the least common denominator. So I have addition, which means I get to add straight across 2x plus 15 all over my common denominator of 3x squared. Nothing factors, nothing can cancel, so that is my final answer. All right, let's kick it up a little bit. Let's take a look at this one. Now my denominator has more terms. So the first thing I'm going to do is if you can break down a denominator, you want to do so, right? Because now if I compare that to the other denominator, there's something in common. So first thing I recommend doing, identify the LCD. The common denominator is every denominator once. Oh, see how that happens? Okay. So let's look at the first fraction. What does the first fraction need in the LCD? Nothing. It's taken care of. So I'm going to leave it as a 4x plus 1 over x plus 2x minus 2. I'm leaving that one alone. Let's look at the second one. What does the second fraction need that it's missing in the LCD? It needs an x plus 2. So let's try that out. I'm going to have 3 times x plus 2 over x minus 2x plus 2. See how I just created a common denominator? Alrighty, let's carry over that least common denominator. Now we're going to have some work to do in that numerator. Let's take a look. I'm going to distribute this 3 first of all, 3x plus 6, and then I can combine like terms. This is adding. So a 3x plus 4x gets me 5x. A 1 plus 6 is a 7. Now there's no way that that numerator is going to factor down further. There's nothing else I can do. So that is my rational expression. Let's keep going. Let's try this one. First thing, I need to identify my LCD, so I see I have a little bit of work to do. I'm hoping one of these is x plus 5, right? If it's the same, that makes it easier. So factors of 25 that get me to 10 would be 5 and 5. Okay. LCD. Here's the exception. I always say the LCD is every denominator once, but you'll notice that the second one has it twice. So if the denominator is the same in the same rational function, you do need to write it twice, okay? Special case here. So let's look at the first fraction. What does the first fraction need that it's missing? It's missing an x plus 5. Okay, let's look at the second fraction. What is it missing? Nothing. It has both of them, right? Okay, so let's take care of that first fraction. 4 times x plus 5 over my LCD, which is x plus 5, x plus 5. I'm going to bring down the rest of the problem. We didn't change a single thing on this one, but we are going to change something. This is a subtracting problem. Watch what I'm going to do here. I'm going to rewrite the numerator as one piece, but I'm subtracting 6x minus 1. See how I did that? So I'm going to distribute, combine. That was a little bit of work there in that numerator, right? This is my numerator. So now I can place that numerator over the common denominator. Now there's no way that that negative 2x plus 21 is going to simplify down to anything that'll cancel. So in this case, that's my answer. Now, I know this topic is a little bit tough, so what we need to work on, I strongly suggest identify the LCD first. Like label that somewhere, keep it written out. It's going to help. Multiply each piece by what it's missing. Now, this is sort of the Mortvet explanation. If this isn't connecting with you, I can certainly share other teachers' videos. That's just the way it sort of clicks with me. But if you need another way, let me know. Okay? Always make sure to simplify, break it down as much as you can. Let me know if you have questions. As always, make sure to check out Google Classroom to see what the task is at hand. We're going to keep working on this topic. So let me know what you need, and until next time, have a good one.